Well, hello everyone, and welcome to today's webinar. We have a really great one today. We're here with Dan Murphy, who fulfills various roles in network security and monitoring from Biscayne DevOps, and he has developed an open source tool that allows you to trigger remote captures called pcapdaemon, and we're going to go into that. So my name is Jason Walls, and I'm from CloudShark, and I'm also here with Tom Peterson from CloudShark, who's going to be showing you some of the live demos at the end. So without further ado, I will give things over to Dan here.
So I wanted to start off with a slide about kind of like how I got here, right? I think our experiences shape us, so obviously that's an important part of this. I've spent most of the past 10 years at DDoS service providers. Prologue is one, if you've heard of them. They were acquired by Akamai. Went with a few friends and started DefenseNet, who was then acquired by F5. But, AOL also kind of fell nicely into this whole thing. And actually the CDN at Tata did as well, which was Big Gravity, where you keep ending up with the same problem, right? You have tons and tons of sites. You have many discrete subsystems within those sites. You have many consumers of data. And then they're all service providers. So really, you're the middleman at the end of the day. You don't own the data. You're just kind of in the middle of it. So you have a need for the multi-tenancy piece, which often is a thing that seems to get left on the floor by vendors. So what are we trying to do here? Anytime you architect any kind of network, you're going to have many span ports, different parts of the network. You multiply that by a bunch of different sites and a bunch of different input systems, and then the consumers of the data, and you kind of find out it can actually turn into a mess pretty quick. You have different consumers like the NOC, the SOC, engineers, sometimes even customers. You're integrating it into your portal. There's a lot of different ways you can go at that. And then customers also want to see the data. It's super important to them. I don't think a week goes by that I don't get asked by somebody for samples of some kind of attack data. And then there's the whole event-driven versus human initiated. I think a lot of times when people think about PCAP, it's, I'm running on a span port, I'm running a tshark or, tcpdump or whatever. And which is super useful, and you're always going to do that. But there's also the event-driven model, which is something I've had a lot of requests to kind of address that, where you just have so many different things that could potentially feed into the capture process. Yeah, and from a time spent on the last bullet point, this is actually a really, really big one in the DDoS world, because you talk about task loading, right? Task loading is the notion that the more things you ask a given person to do, probably the worse they're going to do at them. So you try to not task load people, and especially when you talk about DDoS and a SOC, a lot of times their interaction with the customer is the house is already on fire. So if you're going to ask them to go do all these other things, it just really results in a worse customer experience. So the idea is that, let those guys focus on putting out the fire and let the data gathering be automated as much as it can, and not have to, throw another body at something that is quite easily automated. The DDoS use case. One that I've had to deal with for a bunch of years now, and this is pretty typical in the DDoS world. I've worked at a couple. That industry is pretty close knit, so I've talked to all the other ones, and you kind of end up in the same place where you're trying to look at traffic before it gets to you, before you manipulate it. You want to look at it pre-mitigation, post-mitigation. The GRE, your routed customers always tend to take a different path. Well, not tend to, they do take a different path than your proxy customers, which are kind of the two big dynamics in that world. So you can kind of get a sense that throughout this, count the magnifying glasses, right? Those are all the places where you have a span port where you might want to capture. And, you know, sometimes it's not just on one of those, sometimes it's on a subset of them. You know, you might want to catch something, customer complains about a rule, you might want to catch something pre-mitigation and post-mitigation, and then kind of have those to compare against. Super useful. And simultaneously, right, you need to be able to do it like concurrently at the exact same time frame to know that, like, you know, it's apples to apples, you're looking at the right stuff. And then, you know, take that and explode it out to where you have like a bunch of sites, a bunch of feeders. It's really, that's where it kind of becomes not human doable, right? Like a SOC person, asking a SOC person to do what you saw on the last slide, but now come to this and replicate it across N sites, whatever N is, you know. If the CDN, it was, you know, you're talking like 100 sites. If DDoS, you know, you tend to build bigger scrubbing centers, but fewer of them, but you're still talking about a lot of sites. Probably just not CDN scale. And then on the feeders, you know, even outside of the DDoS, you can think about other things like, okay, SIM is one. You could have an IDS, IPS feeding the capture, like a Suricata. You could have monitoring. It could be like Zabbix and Nagios. And then just pretty much any generic log event. You might have some custom application you wrote that, you know, every Thursday at 10 you see some issue, and you just might want to, based on some event, just kick off a capture and see what the data shows, really. So why CloudShark? I always want to put a slide in here for this because I don't know how many people are new to it, already customers, but I think like the first bullet point really just like is huge, and leveraging industry familiarity is huge because anybody you interview in the security world, they're going to have used Wireshark, right? So to be able to present data in a manner where they're looking at something they've already looked at, they're already familiar with, what you're really doing right there is driving down your time to resolution of like any issue, which is hugely important. I mean, all the SLAs we do are built around that, so that's like a really, really big deal. I mean, who doesn't know what Wireshark is that's in this industry? The annotations, I really like when you have not just geographically distributed sites, but now you have a geographically distributed team. We have, like, you know, my last 3 companies, our team has been spread all around the world, you know, from Hong Kong, Europe, you know, both coasts in the US. It's very typical. So it's great to be looking at the same exact PCAP with the same exact annotations. That thing is like unbelievably useful. But then there's also like the, you know, the compliance part. I don't know how many of the folks out there have to deal with PCI, but we do. It's kind of table stakes in the security world, whether you're doing WAF or DDoS. But, you know, data not being able to leave the data center tends to be one of the tenets of that for the service provider world. So for, you know, if you're actually doing PCI as like a individual who's processing data, it's one thing, but like we don't store that data, but we also have that, you know, we're not going to let any data whatsoever leave the data center. That stuff is really at the behest of your QSA though. You know, and it fits into the infrastructure. I've looked at a lot of these systems over the years. Some are record all the time. Some are, you know, auto trigger, kind of like what we're trying to accomplish here. But what you always look for is things that fit into your infrastructure, like a puzzle piece, and not like an independent ecosystem that you have to build everything around. That kind of ends up in a scenario where you have some really weird vendor lock-in on certain things. But I think like the API that's been provided is actually pretty awesome. We've been able to use it to do all kinds of things, integrate it into our portal, obviously like SOC tools, being able to search through certain things in there. We mentioned the annotations, all that stuff is like hugely important, and just kind of building a more holistic system. All right, so on the pcapdaemon, like, what is it? It's really like an event-driven packet recorder. It's not meant to be a record all the time system like a Moloch or something like that, or if you're familiar with like Extra Hop. There's like a bunch of systems out there. I've looked at most of them over the years that are more record all the time systems. This was actually designed like very specifically to be more geared towards like an event-driven packet recorder. And what that means is like minimal resources required. Like it sits there quietly and just waits for a message, and it doesn't take up any resources. It's very efficient, and you could literally run this on like any host. Whereas the record all the time systems, especially the open source ones, you could not do that. Like they are super fast, super heavy, and need a lot of dedicated resources. There's a toml config. I don't know if you're familiar with that, but it's like very INI based. Pretty simple. It's a JSON message across like a Redis server. It's a Redis channel. Any kind of, you could subscribe to any Redis channel. It's configurable. And then the idea is just to capture and tag, right? Tags in CloudShark are what we use to any type of arbitrary data, right? Like it could be a customer name, it could be an interesting keyword, it could be an attack ID, any kind of event ID that you want to use to essentially tie that to something useful throughout the rest of your infrastructure. And then there's like really two options. One is, obviously it can upload to CloudShark. It doesn't write a file to the file system. It actually like creates it in memory and uploads it directly from memory. You do also have the option to write local. I wanted to mention it, which, it's the second way to actually get into CloudShark, because CloudShark can watch a directory. So you've got a couple options here. So why Golang? I wrote it in Golang, and I think that I just wanted to make a couple, I actually got a couple questions why, so I wanted to do a slide and actually mention. Good portability. I put good in quotes because it's compiled. You have to compile it for the platform you're going to run it on. But the portability is good. You could run this on Windows. It's not locked into like the Unix varieties. The compiler is like super simple. If you look at the instructions in the README, there's like literally 2 commands and you're going to be up and running. It's very, very simple. Concurrency was like a big thing with this because we do lots of simultaneous captures. So I wanted to make sure that there would be good concurrency. And the concurrency patterns in Go, if you've ever used it, is super simple. I mean, they really did a nice job at that. Third-party packages, a big thing. Actually, the last 2 bullet points are kind of semi-related. One of the things I really like about Go is that it takes like the community support, like any packages you use, they actually compile those into the binary. So unlike some of the interpreted languages, you actually you don't have to deploy a bunch of modules along with your stuff. It's actually all compiled in. So the only thing you actually need for pcapdaemon is libpcap on a host, and you're good to go, which makes for super, super simple deployment. And if somebody wants to make a package, it's super simple. So let's move on to the message. So this is kind of like what the JSON message looks like. I just wanted to kind of put a little color around some of these things. Obviously, it's really simple. Most of you guys and girls are going to absolutely recognize. Without me telling you, you're going to understand what these mean. The things that are worth mentioning, though, are like the node and the node RE. They're mutually exclusive. And the idea here is that, I want you to be able to give a node name, but I also want you to be able to give a node regex. A lot of times when you run into lots and lots of systems, like when I was at AOL, I actually ran the MX record. At the beginning of when I was at AOL, I ran the MX record for AOL.com, and it's like we had all our hosts. They had a naming structure, and you might want to capture on all of those. And Node RE is kind of what you'd use to do that. So again, they're mutually exclusive, one or the other, not both. There can be an array of interfaces. Important to note, like you're not stuck to like one interface. And this specific part is really born out of the notion of when you're in any kind of complicated infrastructure, like the diagram I showed earlier, you might have multiple span ports plugged into the same host that you're using to look at all this stuff. So on the same host, it's quite likely that you might have the pre-mitigation, the post-mitigation, so on and so forth. So you might want to just be able to do those on the same host, and hence the need for concurrency on the last slide. So that's kind of where that all ties together. Aliases for grouping, we're going to dig into that a little deeper on the next one. And this can, one of the great things about this will automatically add the tags, like say you're tailing a log file, right? And, I want to capture A, B, and C and just make those tags. You can just pass that along in the message and they'll get tagged in CloudShark. Then you'll be able to search for them in CloudShark and, include them in your portal or kind of do whatever you need to do with them. The config, super simple. If you're noticing a theme here, hopefully it's that Dan likes to keep it simple. And I usually don't talk about myself in the third person, by the way. But reasonable defaults, things like snap length, max packets. Max packets is basically just to protect yourself, so that somebody doesn't do a rule that tries to capture, a terabyte of data. And it's pretty simple. Syslog whatever you do, whatever message you get, and whatever you're going to capture, just syslog it, and you can send that anywhere. It's self-describing. Write local. We kind of touched on that earlier. That's essentially just like write it to a local directory, and you can actually do both. You can write it local, and you can upload it as well. I didn't have a use case for that necessarily, but I didn't want to limit anybody either. I just send all the stuff into CloudShark, so whatever you decide. I did want to spend a little bit of time here on the interface aliases because I think this might not be super clear to people, but interface, in the config, you don't have to define interfaces. It's totally optional. The whole point of defining interfaces, though, is to allow you to, in the message, use interface aliases. And that is useful for scenarios where you have, let's say you have a few hosts all over, in 4 hosts in 4 different locations. Maybe some of them are legacy, right? Nobody has legacy here, right? No. But maybe you have some legacy gear, some non-legacy gear, but they have different interface names and they're on totally different named hosts. But you know for sure, well, I want to X capture on all, well, let's look at our DDoS scenario. I want to do X capture on all post mitigation. You could just create an alias in all the different sites that says post mitigation and then just use that alias. And that way you can kind of cut through all the other stuff and just capture where you need. So it's really a grouping mechanism. It's a grouping mechanism, and this is why I included the diagram beneath it. It's just a grouping mechanism for parts of your infrastructure, for anything really. But for us, it was more parts of the infrastructure than anything. So that was kind of the driving force between with that. And then where to get it. My GitHub, I have a blog where you can read a little bit deeper about it. Definitely let me know what I missed. There are, I'm sure, countless features. I'm happy to add whatever anyone wants. Just engage me and let me know. And that's kind of that's the overview.
Hi everybody, this is Tom from CloudShark. I just wanted to take a second and show you guys pcapdaemon in action. I found this to be useful for development. I have quite a few development machines out in different areas, and while we're troubleshooting, it's very useful to be able to capture from those servers remotely and easily. So right here I have, let me make this a little bigger. Just like Dan mentioned, I have this very simple config over here where I'm uploading my captures to CloudShark. I've configured a Redis server locally here, and then over here I have one of my development machines. I'm running pcapdaemon in the foreground. Normally you'd run this in the background and you wouldn't even need to look at it. But if I need to capture on that machine, I wrote a little script to push my messages to Redis. And that you can see over here in the pcapdaemon debug output. It got a message saying to start capturing. We're going to tag it with a specific tag, and it's uploaded my capture to CloudShark so that I can just browse right to my account. I can look at any tags, maybe the particular development machine I'm on, and search for those in particular. And it's very easy to find a capture that's been started remotely.